Good morning, Morgan, and good morning to any of Morgan's friends that have joined us for this video today. Now, today's video is going to be boring, and I don't know how much use you'll find or get from it, but it's something you have to understand, and that's managing the memory in your on your box, whether it's a server or a PC or whatever. Okay. And that's what we're going to talk about today. And it's not going to make a lot of sense, but you're going to need to know it because it needs to be in that little noggin of yours so that when something triggers it, you'll go, this is weak references. This has to do with managing memory. And with that, let's begin our reading.
Weak references. Python does automatic memory management, reference counting for most objects, and garbage collection to eliminate cycles. The memory is freed shortly after the last reference to it has been eliminated.
The key word there is memory. The memory is freed up.
This approach works fine for most applications, but occasionally there is a need to track objects only as long as they are being used by something else. Unfortunately, just tracking them creates a reference that makes them permanent. The weakref module provides tools for tracking objects without creating a reference. When the object is no longer needed, it is automatically removed from a weakref table and a callback is triggered for weakref objects. Typical applications include caching objects that are expensive to create.
All right. You don't need to know how this works right now. You just need to know that it exists. You need to, the moment that you're going to need to look into this is when you run into the problem where you have to track an object, which is a resource, okay, that somebody else is using, and it's taking up space, okay, and you want your space back. So you have to freaking when are they done? And then when it's released or unlocked, then you can delete it, free up the freaking memory for something a little more useful. All right, here's the code they gave us. It really doesn't make a lot of sense, but since we're here, we're going to go ahead and run it. All right. And here we have the code. It creates an object. And then it deletes the object, and then it goes boom because we deleted the object. All right, and here's the code for that. So here we create this class, and then we create an instance of the class, remember, and then we what do we do here? I don't know what's going on. Weak reference. This must be how you keep track of it. Okay? Like I said, we don't need to know how it works right now. And with that said, let's run it and see what happens. Doop, 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 doop. Oh no! It blew up. It blew up because we deleted it up here in the delete statement. All right? But let's go take a look at the code. Okay? So let's go there. Let's go look at the output. And here we are in the output. Okay, I don't know what these numbers mean, but it outputs them. And then we delete the object. Then we try to read the object again, and it blows up because it doesn't exist anymore. And that, my young Padawans, is the end of this video. I know it doesn't seem very useful now, and I have to be honest, it's not going to be very useful in the future. But we need to know that it exists, so on the rare occasion we run into the problem we have to worry about managing our memory this tightly, you're going to need to know that this is how you do it. And with that, go off, go play, do something entertaining, and don't get in too much trouble. With that, we'll see you in the next video.